What is a correlation analysis? What can it do and what are its limitations? Hi, my name is Fabian Fröser. I'm a professor of business, and in this video I will try to answer these questions. What is a correlation? Let me begin by giving you an example. The more you eat, the rounder you get. That would be a typical example of correlation. Something of this is related to something else. It could be more or less. Now let me follow up with a more formal definition of correlation analysis. A correlation analysis is a statistical method to evaluate the strength of a relationship between two quantitative variables. When we read about correlations, we often can read about the letter R, like small letter R, like Richard. And R stands for the strength of a linear relationship between two variables, and that was invented by Karl Pearson. That's why you also often read about the Pearson coefficient. That's the correlation R. And R is always between -1 and +1. 1 would mean a perfect relationship, and if it's closer to 0, well, it would be a very minor relationship. And we have these relations from minus to plus. Plus means there's an upward relationship. Minus means there's a downward relationship. Let us look at some pictures to illustrate different types of correlations. Let us begin by looking at a more simple picture. You see the slope is going upward, positive. Likewise, this graph shows a relationship of R, which is positive between 0 and +1. 1 would be the perfect slope. And closer to 0, it would be more dots, but still an upward slope. The next picture shows a downward slope. You can see each value goes up and the trend goes down. So it's a negative relationship. Accordingly, the R value would be between 0 and -1. -1 would be the perfect relationship. 1 goes to the right, 1 goes down. X minus 1, epsilon minus 1. Now let us have a look at more relationships that are not as clear. You can see this curve, up, down, up. Maybe it looks like an S if you like. But in terms of correlation R, we will probably think there's no strong relationship, because if X value goes up, epsilon value goes up or down, there's no clear linear trend between this relationship. So there would be a very low correlation, if at all. The next picture shows an inverted U, or a small hill. Values go up and then down. Again, this would mean we have a very poor correlation, because a correlation would assume a linear trend, either upward or downward. In these two pictures, we couldn't really see a clear trend. I've showed you different graphs illustrating correlations. What is also very important is to think about the strengths of the correlation. Are these two variables strongly or weakly correlated? If you simply run statistical analysis, and then you receive significant results, yes, you find a correlation. But what is also then even important, or more important, would be how strong this correlation in fact is. Because if you have large samples, even a very tiny and weak correlation would be statistically significant, but it would be of very minor degree. Here are some rules of thumb. If the R size is below 0.3, we would call it a small effect size. If it's between 0.3 and 0.5, it would be medium effect. And if it's more than 0.5, we would consider this a large or a strong effect. To visualize that, look at these two graphs. You see one graph, you see the line, and you see many dots above and below. So they're very close to the line. So we would say it's a very strong positive correlation. Then take a look at the other figure. There you see many dots here and there. They're diversified and sprinkled all over. Yeah. So there we can still see some kind of positive trend, yeah, but not as clear, and the points are more distant from the plotted line. So that would be a picture of a weak positive correlation. Correlation analysis is a very powerful and useful statistical analysis. You can very quickly look at and analyze relationships between variables. One word of caution, however. It's very important to understand also the limits of correlation analysis. Let me give you one example. The warmer the temperature, the more pirates we have on our planet. And I think that has been shown in data. Would that lead to the conclusion that because we have global warming, we will have more pirates? Not sure about that. The problem is here, correlation analysis cannot establish causality, cause and effect. Correlation cannot establish that. A correlation analysis can only show that there's a certain relationship between two variables. Think of the example, global warming and number of pirates. It's probably not because it gets warmer people become pirates. No, there's probably another reason, another third variable that can explain this relationship. Maybe this relationship has no meaning at all, it's just coincidence. There's other variables that do explain these relationships. We can also say there's omitted variance bias. So there's some variables that can in fact explain certain relationships, but maybe not global warming. And another limitation of correlation analysis also, it cannot establish direction. Which has an effect on what? In which direction it goes? We don't know. It's just a correlation, a relationship between two variables. So I think that is very important to know, that correlation analysis cannot establish causality. We have different types of correlations. The most common type of correlation analysis would be bivariate. Bivariate, as the word implies, bi means two. So there's a correlation between two variables. Of course, in statistical problems, you can just throw in 20 variables and let them correlate. But the correlation analysis will only compute correlations between two variables, one after the other. Typical examples would be Pearson product moment correlation coefficients or Spearman's correlation coefficients. What we do also have, but what we don't use so often, would be partial correlations. That would be to establish relationships between two variables while also controlling other variables. It's also possible. But as we will talk, there are other ways how to add control variables, such as regression analysis, which will be part of a different video. We have reached the end of this video. Correlation analysis can measure the linear relationships between two variables, remember, upward or downward. It's very powerful and can be easily implemented, and it gives you a great overview of data. Unfortunately, it cannot establish causality. For that, you would need different designs and statistical analysis. You will hear more about these different options in my other methods-related videos. For now, I would like to say thank you and bye-bye.